Another draft physics video production presentation. All right, comments. Seems the right thing to do. You either get it or you don't get it. If there's something you're not getting, I guess I need to address it. But some of these comments just are never on the subject. And that's just sort of irritating. Are protons stable? Question mark. Who cares? But yeah, they're pretty stable in the sense that they just don't regularly fall apart. It's not a regular event. It's an event you have to force. Anyway, somehow, and I would argue that we really can't tell because the pieces are so little anyway. But anyway, somehow, by being too isolated, whatever, they could break down in a vacuum of space with what looks like empty space. Whatever, that even. The point is this stuff is momentum, okay? And the argument I'm making that you're not really connecting to apparently at all is that there's these two kinds of things in the universe. There's the force stuff and the matter stuff. And the matter only moves when it has been exposed to more force going one way than going the other way. So somehow it was hit by, if I use the analogy of light and I say the force is light, and if we made all the forces visible, like we could see them all, it would be incredibly bright. Okay, if you could see all the radio waves, if you could see every ray, no matter how short the ray was, every little quanta of energy, if it could be visualized, that we're in a very deep sea of light, and that what we're really looking for is shadows. If there's a shadow, more light on one side than coming from the other side, for obvious reasons. The other guy isn't a mirror, okay? He's not reflecting light back to me. He's absorbing light, so I don't get my share. Then I'm in a field that's causing me to move, okay? I'll absorb force in a direction and move in that direction. So that's what matter's doing. It's collecting. So if it was like a flock of birds and you could put a cage up and you collect the bird flying in a direction, the cage slowly moves in the direction the bird was flying, is the idea. I've used lots of analogies for it, but if you're not going to, you sort of have to deal on the ground I'm arguing. And then you're not arguing conventional physics, you're arguing fringe physics. Speculating physics. And there's just no point in me doing that, frankly. I just couldn't care less, okay, about whether or not a proton is elemental. The point is, in all of the mechanics of the function of atoms and all of the ways you can imagine how the systems work, like magnets, it's not protons exploding, or that's not how it works. The atoms aren't degrading or falling apart or radiating some kind of energy of their own. So that's not the answer. It's like gravity. The answer isn't that the Earth is making it. Okay, it's just stupid to think so. Because its matter's not changing over time. Alright, possible points of origin would solve the problem. I don't even know what that means. But so again, you want to make matter in the universe. You don't need to make it. It already exists. So I don't see the point in making it, frankly. But whatever. Looking for an origin for it when we know it's sort of made in suns. So why am I even bother with the conversation? I don't need some other way to imagine how matter is created when we already know that it's sort of completely the alchemy is taking place in suns. We sort of understand that pressure is critical to changing nuclei. Sort of looks like empty space with what looks like quantum fluctuation. So it amazes me that you'd use a concept, you'd say those words to me like I'm supposed to do something other than make a funny face and say, oh, you just said such a sissy word. I mean, you're just so fucking gay. And you're just like, you're not even trying to seduce me, right? I mean, you can't go just a little bit at a time, you gotta go full gay. I'm just, quantum fluctuation. What is this horse shit? What kind of, made up pile of, nonsense is this? There's no such concept. There's no such thing. It's just nonsense. It's baby talk. You're just talking gibberish. Quantum fluctuations. What is that? Fairy god watermelon? I mean, it doesn't make any sense. What are you talking about? A fairy god watermelon? You can't even bring it into some sort of reasonable context. Okay, over time to start. Well, whatever. Am I expressing my profound disinterest in having a conversation about phantom fairy fluctuations? All right. Though actually consider the damping effect as well in the magnet. Okay, so I suppose he's talking about paramagnetism. And I've already explained it. And so you're telling me to consider something. I've already given you a diagram of how it works. And you're going to sit here and harass me with more baby talk. I mean, what's the point? So I've sort of explained that the magnet has a pole. They shove the pole into a piece of metal. And the simple argument is that what's happening on the metal is you're essentially converting the surface into a reflective surface. So as I've tried to analogize, if you think of the universe full of light and think of the fact that you have two components in you, one that's shiny, that reflects, and one that absorbs, and that you can change your surface like a chameleon, you can change from shiny to opaque, shiny, opaque, shiny, opaque. And so the surface is at this point opaque. And as you move this magnet in, you're going to make it shiny to north poles. Now, it'll be opaque to a south pole, okay? But it's shiny to a north pole. So it's like red and green glasses, or some other way of looking at it is, one can see the one thing, the other one can see the other thing, the one thing. So that's what's taking place here. And so the simple point is the faster you move this in, as you're hitting the surface, right? If you just stayed in one place and you were painting a wall and it sprayed in certain angles, pretty much, you'd keep hitting the same place with the paint, and it would just pile up a bunch of paint in one place. It doesn't do you any good. You're not covering the surface. But the faster you move in, well, then the difference in these angles change, and you start hitting all these other atoms with the paint. So you're spreading it evenly. And the point is every time you hit an atom, you convert it into a mirror. So now you're going to get this back, and it's going to keep bouncing back and forth between you. So you're creating more and more energy, but you're creating a reflective surface. So you need to hit the potential reflective surfaces, because in the future they're going to give you back even more energy. So the more conversions you do, the better off you are. If you keep hitting the same spot, well, yes, you'll get a reflection, but you have to wait the whole time of the reflection to gain any real value from that. And the real value is that the point is now your reflection could hit something that's not reflective, and so you won't have a win there. So the idea is to hit as many, to make as many mirrors first. So the more mirrors you make, the more you get back. So the faster you go in, the more mirrors you're going to make. It takes time for this little reflective bit to pass on its mirrorness. So the mirrorness will fade as the conductor conducts it away. But it takes time for it to conduct the mirror away. So you just don't want to hit the same guy over and over again. You want to hit new ones all the time. So the faster you go in, the more likely you are to hit new and different atoms. And that's the real thing you're after. I pause for a moment. Back. All right. So anyway. So all you're really doing with speed is transferring this medium into a reflector at a faster rate. So every bit of exposure now will get you a reflection, and therefore you're going to increase this pressure between the two objects by creating more opportunity for pressure. The faster you get it done, the more you can take advantage of the fact that they become mirrors. And the slower you go, the more the conductor will conduct all of the mirror away. So if you go too slowly, all the mirror disappears before you can get any rebound out of it at the speed of light. I mean, the speed of light is incredibly fast. But this is also fairly fast, what's happening inside the conductor. So yes, the speed of light is faster than this, but not by enough for you to be casual in creating the event. You have to do it at a certain speed. Now the other side to it is if you go at a certain, insane speed, you won't gain anything out of it because there won't be enough time. There won't be enough exposure to actual photons. So you won't have enough time to convert the surface. So a very high frequency won't gain you anything. All right. A very fast movement. You could be talking about coils, who knows? So that's a whole different argument, because coils create a damping effect by having stored a bunch of energy inside of them. So let me just do the coil argument real quick. So this isn't the coil. Coils don't have anything to do with the paramagnetic effect of creating the same magnetism back at you, and therefore it's repulsive, and therefore you can have mag-left trains and such. But anyway, but the coil is working on a different principle in the sense that it creates a damping effect, if you want to call it that, because what you're basically doing is creating inside the coil the reflective surface. So now all of the energy coming out of the coil, it's hitting another reflective surface. So every piece of momentum, movement, force that you have inside stays inside and just keeps reflecting. So it's like a battery. So all the energy you put in that radiates out of the coil wire, all right, all of that energy stays in and just keeps reflecting, and that's creating a lot of, say, red or whatever color you want to use on the inside. It's collecting it and reflecting it, and it can't get out, so it's stuck inside there, and it takes a while for it to leak out of these two ends. This is the only way it can get out, is it has to bounce, 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 and then fly out the end. So it takes a while to get to the end to get the hell out. So it doesn't drain right away. And so that creates a system where you can turn off the power, but you still have a bunch of energy inside the coil, and it'll keep pushing that electricity out the wires. Alright, though actually, consider the damping effects as well in the magnet. More electrons push to the magnetic damping effect. So again, people keep talking as if electrons are going somewhere. All you have to do to an electron is move it closer or further away from its proton, and you've created a little magnet. And that's what you're really doing, is making something magnetic. You're creating a north pole or a south pole on the surface of something. You're not really moving electrons. I mean, they're not flying back and forth. Electrons aren't going anywhere, really. They're being moved like this from position A to position B, but they're not really going to position C. Okay. Effect will be greatly increased. More electrons pushed to the magnetic damping effect will be greatly. So again, yes, you have to. Pushing the electron is changing the polarization of the atom. So yes, and if you change the polarization of the atom, you make it a north side, and you're facing it with a north magnet, well, then you're going to have repulsion. It is true that the copper coil, so now he's on coils, can do this, but the magnet can't. Well, I don't know how many effects you want me to. I mean, there's paramagnetism that creates a magnetic effect and something non-magnetic. Now, if I put an iron coil inside of here, what's happening is now I'm exposing the iron to a whole bunch of magnetism. I'm magnetizing it. I'm telling the iron core to line up. I'm obliging it to line up with the magnetic field I'm creating inside. And that's what it's going to do. And it's all one field. So in a sense, the iron core is going to want to just fly the fuck out, because it's saying I have two poles. The iron core is going to try to create a positive and a negative. Well, it's stuck inside of a field that's going to be mostly one thing. And so it's going to reject being in that field because it can't find balance in that field. But if you force the ferromagnetic material to sit in here, it'll create a positive and a negative magnet. That's going to be much stronger, because now you've even increased even more the reflections. They're even happening faster because you've changed the stuff doesn't, you can think of it just as a simple argument. The reflections now don't have to go all the way across and all the way back across and all the way back across. Now that you've stuck something in that can go magnetic, now all the reflections have to do is this little distance. So you can understand, when I've done this little distance thing, I've greatly magnified the pressure. So the number of impacts, if I have a ping pong paddle and I change I'm greatly increasing the number of impacts, and each impact is a piece of momentum being transferred. So the more impacts I make, the more momentum I'm transferring, and I'm transferring them clearly in very specific directions. Obviously, these directions would cancel out, and these directions would be powerful. And but that's what so that's the concept. The putting the core in just makes more shiny surface closer to the other shiny surface, and therefore even more reflections. All right. Let's see. Or is there something missing? Whatever. You're too vague, okay, and you're not citing something that can be rationally compared. Their model, their explanation versus my explanation. But I can't. This vagueness just makes it really difficult to address specifically what you're saying. I can't even figure that out. The difference between a coil and a magnet is that the coil keeps the charge in circulation. Is this correct? Clearly, that's exactly the point. It's trapped inside the coil. Okay, the mirror surface is inside the coil, and you're getting the reflection. So yes, it's a kind of a battery. It's a storage device. Is there a difference between the shielding in a coil and the shielding by a copper plate? Well, obviously coils aren't as perfect as a plate, but you can't run current. You can't force the spreading of the... See, the great thing about a thin wire, is that if you put the electricity in, you're going to get a lot out in terms of mirroring the surface. But when you put electricity through a plate, the electricity can take one path, or primarily one path, substantially one path. 70% of the path won't change, let's say. So you're not polarizing the atoms very much. So you're not going to gain much. Where the wire, you have a much higher likelihood of polarizing all the atoms. The smaller the wire, the smaller the surface. Clearly one has a steady state circulation, but the other has a dissipation problem. Well, I guess that's what I just said, but okay. Other random redirections are enough to demagnetize the copper plate. I don't know about random redirections, but clearly the copper plate can choose one path that doesn't expose it to many of the atoms. So very few of the atoms will be involved in the process of transmitting the electricity, where in the wire, like, all of the atoms are involved in transmitting the electricity. Also, let me go out on a limb and say this: reflections, so that there hasn't been more discussion about this subject. So let me go out on a limb and say this: reflections. So that there hasn't been more discussion on this subject. So I don't know what that was when you typed it in whatever language you speak, but it didn't come out in English very good. I don't observe gravity itself, but only it seems to be happening. Well, we don't observe anything in and of itself, frankly. Everything is the small universe is really small. The atom is to the apple what the apple is to the earth, kind of thing. It's all really small stuff. We don't really see any of it. Even the photons we're seeing is, they have to be a certain ray length and a certain polarization and blah, 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 blah. So we're not really seeing. And again, what are we seeing? We're seeing electrons being moved by the photons. So it's a little bit, everything has to be understood this way, by modeling it. You can't understand it by just saying, I feel it. It's like saying you don't understand heat by feeling heat. The density and spread of the trapped bits moving in straight lines are going to make objects converge. Or diverge is the whole point. But for every now and then they stick to the redirections of electrons. I don't know. Sorry, can't make anything out of that either. We see light from very far away galaxies and get decent images. So except for the straight lines, they are going to make rays travel into infinitely large images as well. So except for the straight lines, they are going to make rays travel to infinitely large images as well. Well, the point is there's an image of everything everywhere. There's an insane multitude. See, I can just move over here and I can move over here, and the image I'm getting from the camera, or whatever I'm looking at, is always there. So everywhere I go, there's an image of the object. So yes, we're just selecting, because of a pupil, we're selecting one set of rays bending in specific ways, diverging in specific ways, and we're not seeing all the other rays diverging in all kinds of other ways, because we have a little tiny pupil and it's doing the whole lensing thing. It's rebending the light and spreading it over the surface of our retina. So our images are kind of an illusion of reality, because in reality, if I put a plain piece of film out, as I pointed out, I'm not going to get any image. I'm going to get a ton of images, pieces of the big images, pieces, and all of it's going to be mixed up, and I'm not going to get anything coherent. So yeah, it has to be understood that the images are being formed from tiny little points on a surface, and the image, each microsecond, however you want to say that, each tiny piece of time, the photon can be going all kinds of different directions. And so at each moment, one moment it shoots a photon this way, and the next moment it shoots one that way, and the next moment it shoots one that way. And that variability of where the photons are going means there's variable images in all kinds of different space, but they're all different photons. All right. I appreciate the comment, appreciate you trying, but yeah, it's unfortunate that there's some language barrier. Maybe you could say what your regular language is, and then maybe somebody on this board is better at translating it than the computer you're using or whatever you're using to translate it. Anyway, Pervaction. I didn't post a link because I'm figuratively tied to a hospital bed and can't access YouTube only via phone app. Well, that's, sort of just announcing something rather extraordinary and bold. I mean, so there's not going to be an explanation. some kind of anal surgery. I don't know, what. Anyway, on which I can't find a link to copy, and the share function doesn't extend to YouTube comments. Well, I'm not going to fault. All you have to say is you're disabled at the moment, and that's why you didn't post a link. Okay, no big deal. So I just kept it to the literally best search tags and spared you the explanation. Yes, I mean, fruit flies in microwave was probably enough. But anyway, thank you. Now, verbally vindicate me, please, LOL. Well, I don't know if it's a complete vindication. I mean, it just sounds like kind of a lame excuse. Like I couldn't email somebody else and say, "Oh, could you post this on YouTube for me with this link?" I mean, you could have taken some, you could have blinked your eyes from the bed in a certain way, and then people would know what you're saying, and something like that, maybe. But anyway, sorry. I mean, that's all I can know. It's creepy. Hospitals are horrible places, and horrible things happen there. So, sorry. Anyway. Oh dear, it's the same guy again, right? It's the same. Oh, alright. Yeah, that's right. Did I delete your post just now? I didn't just do that, did I? Oh, no, I didn't. Okay, yeah, so it's the same guy again. Oh, okay. Alright, well, here we go. Well, try to be understanding, whatever. Whatever. I'll try to endure the difficulty. If gravity comes in bits moving in straight lines, are they going to do the same in electrons? Are they going to do the same in electrons? No, electrons aren't the same as the force, and as I pointed out, electrons are kind of a wacky boat in the sense that they can't absorb energy in even amounts. So when you're absorbing energy, as I've pointed out, you're making an exchange when you're reflecting or when you're absorbing. And the idea is the matter bit, gets hit by a force bit and it makes an exchange. It says, I have certain things inside of me, I got rubber duck, I got frog, got different stuff. So you give me something and I'll give you back what I got. And that's sort of the exchange that takes place. And it might be a composite of the two or some other kind of thing, but I'm just saying there'll be an exchange made with the object, and it will keep this stuff, momentum this way, and it gives back, I think, probably only momentum in the opposite direction, but who knows what the exact rules are yet. I haven't figured all those out. But there's an exchange made, and so the electron is what's hit it. And the point is it'd be fine if you could say, okay, it's exchanging momentum in packets, that it has. But the point is, if it has an odd number of packets, well, then it can only have at any one time, it can only have 3 things going this way and 2 things going that way, or 3 things going this way and 2 things. It can only have imbalanced relationships here. And so then the electron has always got a bias in a direction. It's always wobbling through space. It just can't do straight line. Perfectly straight line. Now, if you put it in a magnetic field, you can compensate for that effect by forcing a bunch of balancing force. And so you're shoving a bunch of energy in that will take the jitter out. It won't allow it to do this anymore. It can only do this. So it'll fly a straighter line. Alright. Actually, I have some trouble understanding. We observe gravity, but only feel it from all those redirections. I don't know. Alright, but let's do a quickie on gravity, just because people still think that gravity has to be made by the object interacting, and that's really not how it works. So what's happening is as an object collects things from gravity, its gravity increases. So the more crap you have inside of you, right, and the closer that crap is to each other, the higher the density, the more you're going to pull more stuff in. So the more this gravity that ends up getting created. And what creates the gravity? Well, I'm arguing what's creating the gravity is motion. Okay, when you move an electron, it means it did actually have to absorb something. Something had to go inside of it and not go out in the same direction it was going. So you're stopping energy from getting to another surface, and that's what's creating the gravity. And so every time an object starts getting bigger, all of these things inside aren't just sitting there going, I'm just sitting here minding my own business. They're all moving, okay, because they're all still absorbing more energy one way than the other. Like this object over here is saying, this guy and this guy and this guy and this guy are all absorbing energy this way that doesn't get to me. And so I'm getting pulled into this part because I'm on this imbalanced side of the earth, right? There's a lot more mass this way than there is this way, and there's energy coming in all the time in these directions, and they're absorbing it. So they are actually moving a little bit that way, and when they move, that means they ate this. That means this didn't exist because they ate it and are moving really, really slow, so that force doesn't get to me, blah, 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 blah. So there's all kinds of motion inside of the object. Now, some of that motion you don't see. Right now, we're moving. As a physical fact, your atomic particles are moving. Okay? That's why you're imposing pressure on your chair or on your feet, is because you are actually moving. Okay? You actually have to keep pushing on the ground. You don't just push on it when you sit on the chair and that's it. No more pushing. No, you're constantly pushing. And you're constantly pushing because you're constantly absorbing force to move in a direction. Now, the Earth is going to push you back, but that's really not relevant, to the conversation in some respects. Because the only part that matters is the part when you're making gravity. It's all about the stuff leaving you, right? And when you're receiving, being affected by gravity, it's only about what's coming at you, right? So the stuff going this way doesn't matter when you're in this position, and the stuff coming towards you doesn't matter when you're in this position. And that's sort of the way it works, is you only see one side of the effect. You don't see the gravity you're making, is the point. By going into the Earth, you're actually, by pushing into the Earth, you're creating gravity above you. So other things will be affected by the fact that you're absorbing energy by being pushed back up again, right? So you're absorbing it going down, you're absorbing it going back up again. And the point is that when you add that circular whatever up from something coming this way, it's not going to notice the absorption of energy going this way because that energy already went past it. See, I mean, I can't be affected by something that's ahead of me, okay? Whatever it does, who cares? The stuff that matters is the stuff that's coming at me. And if that has changed, then the field I'm going to be affected by has changed. What this thing that absorbs energy going the same way I'm going, you can sort of understand from this guy's perspective, he could care less about that balancing energy, right? The yang part. He can't see yang. Yang is totally irrelevant. This arrow is going to get absorbed and cause gravity, cause a shadow over here. Well, that shadow can't possibly impact this guy. He couldn't care less. It can't mean anything because that energy isn't going to have anything to do with him. Energy going that way doesn't have anything to do with this guy. The only thing that has something to do with him is the energy going this way. So all that matters to this one is how much of this have you blocked, not how much going this way. So this guy over here getting blocked can't mean anything to him. So you only see one side of the yin-yang. You only see one side of the energy conservation. And by seeing only one side of it, or being affected by one part of it, means that everything, the guy coming over here, that's where the conservation comes in, is the other guy over here is seeing exactly the opposite. So you're seeing all red, he's seeing all blue, however you want to look at it. So it ends up being conservative in the end, but it's not. And then so the gravity you fall into doesn't have anything to do with the gravity you're making, theoretically. Okay, the object already has spread over its entity, okay, this imbalance where it's absorbing something in every direction. Okay, so It's just a fact. It's stuff is being moved, therefore it's an absorption. And then, so you're falling into gravity already made by the stuff on the surface. All this mass, this is already creating gravity, and it's going in all directions. And then when you show up, yes, you're creating more gravity effects, more shadows, if you want to call them that. But they're really not essential. Because you're a tiny fraction of the mass of the Earth. So it doesn't mean anything. And the gravity, the reflection, the shadow, however you want to look at it, doesn't come back to you, right back to you. So this interaction, when you're causing gravity, that is when you're making your shadow, the reflection, the motion of the object doesn't have to be towards you to count as your gravity. All it has to do is have a vector that has a portion in this direction. So any motion in any one of these directions, right, by this object will count as moving towards you because it has a component in this direction. So all it needs is a component. Okay, one component. Okay, I should draw the lines this way. It just needs a component in this direction. It doesn't need to be explicitly going in your direction. So when you're creating gravity, you're actually creating it in all of these angles. So your gravity comes back at you, your reflection in gravity comes back at you in all of these angles. That's why gravity is a weak force, right? I mean, you're creating motion in this direction, you're creating this shadow, and the consequence of the shadow isn't over, it doesn't come back off this little tiny area, it's spread over the entire surface of the Earth in terms of things moving, bits of the Earth moving in all of those directions. So so everything that creates gravity is doing this. So it doesn't matter what position I'm in, it doesn't matter where I move to, the gravity I'm making is the same at every location. It's a 0.2 here, and it's a 0.2 here, and it's a 0.2 here. It's a 0.2 everywhere because it's every motion possible in those directions will be counted as an absorption in my direction. So so the speed of the force is irrelevant because the force is happening in all the locations. The effect happens over the whole 180 degrees of the sphere. You don't communicate directly back and forth. You're not an electron. All right. So there should be enough, let's see. We observe gravity but only feel it from those redirections. So that there should be enough to count. I don't know what that means. But could your force bits flying be so dense? What does that even mean? Obviously the force has to be incredibly dense. You know how much light it would take to move something physically heavy? I mean, just anything I can imagine. How many megawatts of electricity it takes to move something? And gravity's doing it all the time. I mean, the horsepower gravity imposes is insane when you think about it. So, I mean, obviously it has to be insanely dense. Yes. The only bits that exist are those that create waves. Oh, fuck you. This obviously won't be your answer. So why just say it? You don't have any evidence for the existence of any waves. You just don't. You have mush. You are dead right. Of course, density is not a problem. So he's talking about something specific to the video, I guess. I don't know what that means. But their density seems unlikely to me. So again, I can't imagine what that means. Since we see light lines, we don't see light. We see electrons get moved. Okay, so we're not seeing the quanta. And again, I mean, it's sort of already a well-established fact that we need a ray of light that has 6 components in it to see it. If the ray isn't 6 components long, you don't see it. Doesn't mean it doesn't exist. It just means your electrons don't register it. since we see light lines go the opposite direction of gravity, and again, why shouldn't they? I mean, I've drawn this stuff so many fucking times, but I mean, even if the force hits force, you can't tell the difference, okay? I mean, if there's a reflection of two things that are the same, well, guess what? It's going to look exactly like missing. Missing looks like this. Hitting looks like this. You can't see that this is exactly the same as that. Shit. Alright, anyway. This is just tedious after a while. Let's see. The light could just be a reverse of gravity in that case. It's just silly. Light is clearly at a frequency, for fuck's sake. And gravity doesn't have to be. More electrons on the surface. Gravity is essentially all those little rays your eyes can't see. More electrons on the surface are pushed into the Earth by gravity and out of the Earth by infrared radiation. More electrons on the surface are pushed in the Earth by gravity and out of the Earth by infrared radiation. Infrared radiation is the evidence of the heat. That's the evidence of the movement. So yes, the bigger the object gets, the more motion that's happening inside of it. That means the more friction between the atoms. That means the more photons you're going to create. Think of light as, no, I don't want to do it your way, as leakage of the pipes while the gravity is the air pushing everything into the pipe. Yeah, well, wouldn't it just be easier just to say what goes in has to come out? So it goes in one form and it comes out in another form. But they're both heat, technically, right? All motion is a kind of heat. It's just in a different form. Shit. I mean, there's lots of ways of saying it. Leaky pipes, well, okay, if that's what you want to call friction, or that's what you want to call, let's see, what's another word for it? The fact that atoms are rigid and there's a consequence to banging them into each other. But then the question arises, why doesn't gravity induce circuits like circuits induce light? Well, because it's not the proper, you have to have the proper conductor. The Earth isn't a proper conductor would be one of the obvious answers. It's a really shitty conductor. I mean, as much as the ground conducts, it conducts because there's moisture in it. The drier I make it, the shittier a conductor it becomes. I mean, if you take a copper rod, a lightning rod, and stick it in 10 feet of sand, and the sand is dry, it's not going to work. Okay. If they're both reverses of each other, whatever, I have a suspicion that we haven't discovered all the phenomenon we could make use of. Well, duh. But do we have enough evidence to deduce rational conclusions? And to make deductions like physics should be physical? I mean, we shouldn't establish causes where we basically just say phantom gremlins, right? And you just use that fucking rhetoric to me. Phantom fluctuations. I mean, what the fuck is that shit? Come on. For example, all I need is stars shooting light rays in gravity to be retraced to its origin point, the ground of all grounds. Whatever that even means, I have no... If we find the origin point, whatever. I mean, what do you need the origin point to do physics for? The origin point isn't going to give you any answers. I'm sorry, it really isn't going to be that interesting. I mean, you all think there's some big interesting thing about the origin, but it's not going to be interesting at all. It's going to be just as mechanical as all these other processes. It would act as a spontaneous... There's no spontaneous... I'm sorry, silly talk. Breakdown where the gravity and light reverse roll. So again, it's just silly. Light is, give me a real argument. If you're gonna cite something, if you're gonna make some assertions then assert them with some evidence. Cite a fucking experiment that demonstrates that gravity is the reverse of light. Light is these little bits at a fucking distance, okay? This is officially what light is. It has a fucking frequency, for fuck's sake, and it's very specific. We can only detect it if this frequency is consistent. Change this distance a little bit and the whole thing fucking breaks down. Right? So what the fuck are you talking about? How's there an opposite of that? There's no fucking opposite of that. The point being made is, no, there can be this stuff and it can have eccentric polarization. So it could be at the right frequency, but it's coming, the gun is shooting so scattered that this can't be interpreted by a substance. Now, steel, it wouldn't matter because steel is all the atoms are connected, so it can, when the first hit happens and the B hit happens and the C hit happens, it can add them all up because the different atoms are communicating with each other, and this one says, I see the A, and this one says, I see the C, I see the B, so they add it all up and they spell the fucking word, okay? So, yeah, metals can conduct this stuff and collect it. So it doesn't matter sometimes if it's way out of polarization. But the thing you can't fix is phase. So if you change the phase of this, well, yeah, then you've lost your frequency. And this is what we're detecting. The frequency is essential to being able to push the electron. So as I've explained before. But I'm just saying, so all gravity is this stuff, okay, except there's only one of them. Or maybe there's two of them. Maybe there's three of them. All right, and we only have instruments that can collect 4 of them. Okay, and as soon as we set our instrument, our best one, like our photo multiplier, we set it to be really, really sensitive, what happens to it? It says, photon, 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 photon. It goes insane. No matter where we put it, it starts going insane. Well, why is it going insane? Oh, because it's detecting all of this and all of this, these little rays that are coming through the ground, going through everything. All of these little rays, and the ones that have very close frequencies, all of them, okay, are around us all the time, and that's what the photo detector is picking up, and it's just saying, there's too much light. I can't just differentiate. I'm seeing light all the time. Everywhere I look, there's light because it's seeing these little tiny rays, and these little tiny rays are gravity. Okay, so it's not the opposite of photons. It's exactly the same as photons, except it doesn't have this precision in it. It's pieces of the music. The electron can only hear boo beep boo, right? You can only hear some sort of what do you call it when there's more than a few notes? A little bar of music. But there's all kinds of pieces. There's all kinds of notes in the universe. It's full of notes. The electron can only be affected by specific notes in specific arrangement. And as I've explained before, that is because the electron is in tension. It's a spring. It's a tight fabric. It's a, however you want to understand, it's in tension with other objects that are forcing it to be in a position. And if you move it from that position, you hit it, it's going to rebound. Okay, it's rubbery, and it's going to tend to want to go back. And so if you hit it at a slow frequency, very long distance between the objects you hit it with, well, then it only goes over here, and like a pendulum, it swings back, and then you hit it again, and then it swings back, and then you hit it again, and it swings back. If you want to get this electron out of the tension, you want to get it over here, you have to hit it very quickly with hunks of momentum, so you push it faster than it can rebound. So you hit it, it rebounds a tiny bit. Then you hit it again, it rebounds a tiny bit. You hit it again, it rebounds a tiny bit. That's how you get it somewhere. You can't get it somewhere unless you hit it with a high enough frequency to push it out of its tension. So that's the simple argument about why our instruments can do this. It can detect when electrons move this far. It can't see electrons that go this far. It doesn't create any electromagnetic phenomena. It doesn't create electricity. So we can't see that. We can only see when it pushes an electron this far. So this is all we can see, is energy that comes in fast enough to cause that event. And as I was pointing out, conductors make it possible for atoms to share that pressure and impose it on one electron. So you sort of understand that the energy goes in. I really don't want to get into these kind of specifics, but you can sort of understand that the idea would be that the pressure, okay, if you have connected atoms, the pressure can go in, okay, and the idea is that represents movement, and this one can share the movement. So this one gets a little bit of it, and this one has a little bit, and this one has a little bit of it. And the idea is it's really going to travel across the atom, and at some point that pressure for this atom to be neutral again, that pressure has to be released. And so instead of all the atoms releasing a little bit of movement in their electrons, one of the atoms releases the electron. And by release, I don't mean it really releases. I mean it pushes it far enough to send a pure signal to another atom that this is how much pressure came in. This momentum of this electron is what essentially jumps. The momentum, instead of the electron jumping back, falling back, it jumps into the next atom, and that atom jumps an electron out, and the next atom jumps an electron out. So they're just pushing electrons instead of transmitting it the hard way by quanta of energy. And then you have electricity. Spontaneous, though, it's an illegal word. So you have to defend the existence of your spontaneous, and certainly if you're going to say silly things like quantum fluctuations, you have to defend that with some sort of evidence that there's any such fucking thing, that isn't just a bunch of made up crap for which there's no evidence that anything ever quantumly fluctuated. Alright. If I had to deal with such moronic comments, I would have been an anti-natalist as well. Catch my drift. Well, I mean, you're not really. It's not really a piece of driftwood. I mean, you're being pretty explicit. But yes, I get the point. Yes, the whole reason why I'm anti-natalist is I've met human beings and they're pieces of shit. Yeah, my experience with them has not been enjoyable. So yeah, I get it. They're assholes. I mean, the animals are assholes too, but they don't have the, they have the innocence of ignorance, or real ignorance. Now, you can say that dumb people are dumb people, but they're not dumb, okay, in the sense that they can know they're dumb. They can look at themselves and say, man, I'm an asshole. They can just, anywhere, they can look in a mirror and see it. It's written all over them, and they're pretending there's something else. And that's the bullshit. So yes, humans suck because they're so aggressive in their pretending to be doing something better than being an asshole. Another instant classic of your comedy was Virtual Mush. Okay, well, whatever. Different strokes, different folks, but yeah. I am sometimes, unintentionally, pretty much. Humorous. Not my fault. I didn't mean it. Alright, so this person's kind of just being an asshole. What you need is evidence. Well, what you need is an explanation. So he posts a link with no context. So there's a guy who says, yeah, what you need is evidence. And what you also need, though, is some sort of reasoning. Okay, you can't just throw the evidence on the table and say, there, I'm not going to explain it. Okay, yeah, I'm not going to tell you where I found the gun. It's just a gun. I'm going to give you a gun. I'm not going to explain the connection between the gun and the fingerprints, or the gun and the ballistics, or no, I'm just going to throw the bullet, throw the gun, and just say, there, convict the guy. Well, that's sort of bullshit, isn't it, Mr. Evidence Needer? Alright, so this is an old Distinti video. I mean, I hate to even link to this douchebag. So he makes a video on polarization, so I guess I can show you that. Well, first we have to do the 15-minute ad thing. And parts of his videos aren't bad. I mean, he's playing around with stuff and picking apart the classical explanation, which is great, because it's junk. But he's still wrong in his understanding, so he's not getting polarization right either. All right, so anyway, he makes this video. It's not real polarization. Well, circular polarization is real polarization, but it's understanding what the consequence of polarization is. I mean, you don't get to polarize, you don't create a polarizing filter for free. That's sort of the point. So he gets to it sort of. I mean, he does use the word phase, which is really important. But so, and then he makes another video. He says right in this video, well, if you want to know how it works, you know, become a Patreon member. So I mean, that's such a dick move. That he's, you know, despisable just for that kind of horse shit. I mean, that's just so scientific. You know, it'd be great if all the greats of science did that kind of horse shit. You know, pay me or, you know, buy my book. You know, that's just horse shit. So fuck you. I mean, you know, find some other way. I mean, you know, you can't beg for money honorably. You can't just say, and look, just say in all your videos, look, I mean, I guess it's hard work. Give me some money, please, 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 please. It'll work. I mean, you remind people that, you know, it's tough being a scientist and they'll pay you. But I mean, this idea of, you know, first you have the commercials. I mean, that's kind of rude. And then on top of that, you have to sit there and tell people you got to pay a membership. You got to join my club. Or I'm not going to tell you what the truth is. I mean, Jesus. Fuck you. That's just so bogus. But anyway, alright. So the video just basically is pointing out how, look, this can't be circular polarization because look at this effect and look at this effect. So we're just talking about the polarizing film again. And he does use the word phase. And this is all these, so all he should just say, as some guy's video on the internet does explain it, these polarized glasses are nothing, okay? This is a filter going this way. This is a filter going this way. And all they've done is add a clear piece of plastic, a very thin film, right? This is a whole part of physics, is the optics of thin films. And so a thin film is on one side, and all the thin film does, right, is change the phase. That's all it does. It just retards the phase. So the thin film, its purpose is just to do one thing. So the light goes in this way, and its only function is to change the phase by 180 degrees. So if there was two light beams, one that goes through and one that misses, the point would be is this one's going to get out earlier than this one. This one's going to have to take time to go through the thin film. And so it's going to be a little behind this one. So this one's here, and this one's here, and this one's here, and this one's here. You see, that's all it's doing. So the thin film is just changing the phase. So you're changing the phase on this filter. All right? And now the movie is being made knowing that. So it's done the same thing. It's retarding the photons, essentially, retarding their production onto the film by the same phase change that this thin film is going to create. And so now they can do this 3D thing without creating the defects in the film. So now you can have a film that you can watch without the glasses and a film you can watch with the glasses, and you can't, you know, you won't see the, if they'd use the color thing, then you see the stupid mixed colors and it just screws it up. But this makes it in kind of an invisible, so you can have a 3D film that you can watch in 2D, you know, without 3D glasses. But anyway, so it's, but yeah, it's not circularly, there's no light that's going through because its polarization is circular. It's just a phase change. That's it. Nothing else in polarization changed. You still have filtering for light going this way or filtering for light going that way. And what going means, as I've pointed out, it means it has irregularities going this way. The gun's wobbling this way when it's shooting. So you can sort of understand that an electron isn't going to necessarily, when it's getting moved, and that's when it's creating the photon, right? When it moved to a new location. Well, it's going to move back on an atom that's probably just jiggling one way or the other. It isn't going every direction. So it's not jiggling like this. At any one moment, it's jiggling in a specific direction, okay? This is how, so if you had something bouncing inside of a circle, you could sort of understand that at any one moment, it's going to bounce in any one direction, okay? But it's not going to bounce in all of the directions at once. So if the photon's being released after it hits here and it's going this way, this way, this way, this way, this is the linear polarization, because the electron in the atom was moving this way when it was emitting the photon. So it has some irregularity this way, or the gun can be moving this way, or your gun can be moving this way as you're firing the bullets. And again, polarization is just, the fact is the quicker I fire the bullets, the less my movement matters, right? So the faster I'm shooting the bullets, the less this movement matters. If I fire them really, really fast, I don't even move at all. But the slower I fire them, oh, then my polarization starts getting sloppy. When you get to radio waves, they can be polarized, they can be out of alignment in 2 dimensions. You know, they're not only out of alignment this up and down, but they're also out of alignment in and out. Okay? So the longer the frequency, the more possible it is to create something that has polarization that's technically, you know, like I'm sort of saying, is that the ray going into the board, right? I'm shooting the ray into the board. The little bits of the quanta can be in any one of these positions. The longer the wavelength, so the greater the distance between the little bullets, the more irregular the alignment of the ray. So the ray isn't really a ray when it's long wavelength radiation, long distances between bullets. The ray gets really sloppy as a ray in terms of where the bits are. I don't mean that they're moving in these swervy directions, but where the bits are gets more and more unray-like. And the tighter the frequency, the faster you've shot them, the less the gun wobbled, and the straighter this ray is, the more narrow that ray is. So the ray is fat. You could just say when it's radio waves, it's pretty fat, and it's really thin when it's visible light. Alright. But yeah, there's no point in playing this. And so his explanation is, again, he you know, it's in spite of being the de Sitter thing going way back to particle gravity, he still buys into a bunch of wave bullshit. So his theory is going to be, his explanation is probably fundamentally wrong, because I don't think he understands there's no fucking waves, asshole. So, but again, this video is absolutely useless in the sense that it's just clickbait in the worst kind of way. Pay me to give you the answer. Just shyster science, pretty much. So fuck you for posting it as an anonymous link. Why don't you just fess up? What's the point of it? I mean, realistically, he doesn't even point out how the only difference between the two sides, right? There's polarizing filters. One's going this way, one's going that way. You can see that part. It's obvious. And the only other difference is one has a little piece of extra plastic put on it, so it creates a phase shift. And as I don't know if I explained the phase. I explained the phase shift, right? I mean, I explained to you that if I move the phase of a photon, if I change one bit, so the photon has a ray, and there's a little tiny misalignment of the ray. You know, there's some misalignment in how they're fired, and so this one hits the bar, and the bar is going to create a phase shift, okay, of whatever, 90 degrees. 90 degrees means it's going to line up here. So this one took longer because it got phase shift by going through the bar. So you can sort of understand this one got slowed down, essentially, right? It didn't slow down, it got slowed down. Its progress got retarded by going through the bar, by going through the clear film in the polarizing film. So the polarizer is basically just clear film, no film, clear film, no film, sort of saying. Or you could just say double film, single film, double film, single film. So it's always getting shifted by this 90 degrees. So you could just say, yeah, 180 doesn't matter, you know, it's invisible, and then 90 would be visible again. So you can sort of understand that if I put two phase shifts on, I've undone the phase shift. And if I get the 90 degrees, then I've, you know, and so you're just saying, see, if I go 180, so if this is 90, and I go 180, well, I'll be back on phase again, right? I'll be back in alignment. So, but anyway, so the point is that the one photon hits the film and it gets retarded. So it ends up essentially here. It ends up in the same location in space, so to speak, as this bit. And then what's happened to the frequency now? Well, now the frequency isn't consistent. So now you don't have your minimum of 4 or 5 of these things at exactly the same distance that your radio receiver needs. The receiver, your eye, a radio receiver, all these things need a very specific frequency. They can't see without the specific frequency. So if I take one of these out and I move it over here, it can't see the frequency anymore. And then what you can do is retard these 3, have them hit one of these bars, and now they'll be retarded in their progress, and they'll have the same frequency now as this one, so it essentially just pops this one back in its right place, and now you can see the photon. I mean, it's a perfect explanation of polarization. I mean, it works. It explains what we see in the experiments. So anyway, enough. So, till the next time and such, I guess it is like Thanksgiving or something. Who cares? But anyway, whoop-de-doo. So, whatever. Tolerable and whatnot for all you people out there. I mean, if you're listening to this video, you're probably not having a great Thanksgiving. So, my condolences then. And such. So, yeah. It's kind of a holiday jacket. Okay. I'll pretend I'm acknowledging something, but anyway, I'm really not. But anyway, till next time.